Hello, the stream has started and I am about ready to start. I need to go do something. I'll be right back. So sit tight. I'll be right back. I wish I had a sign I could put up like BRB. Maybe, hang on. Anyway, I'll be right back. Okay. Hello, I'm back. I need to change the stream title. I guess I can do that after the fact, but I do like for it to, broadcast what I'm actually doing. So, let's see. I don't have my stream manager up, so I don't know if anyone's watching. Looks like not yet, or I don't know. It's hard to tell. The stream manager is always a little bit of a lag. Let me. Yes, Twitch is cool, but sometimes it's like finding things is a little weird. So I'm going to like the stream title is still showing DGST 101 section 2, which was the last stream I did on Wednesday. So let me change the title, although I think you'll still see the same title as it broadcasts. What am I doing today? I don't know. What to call this? More fun with engrams? I don't know. So I've been working on several things that I wanted to show you how to work with yourself. And yeah, so I'll share the. I've got a notebook that's working. It's still going. I will share this. I'm a little nervous about sharing it because I don't want to stop the process. I don't know, so if you can see this process that's been running in this cell, has been going for about 15 minutes so far. And I'm afraid it's gonna stop if I share it, but it looks like it's not. Okay, so okay, hopefully that's gonna work. Yeah, it's still going. Okay, good. So let me put this in the live stream channel. So, hi everyone. Here's the Ngram Explorer notebook I'm working on today. So this is mostly to answer a question or like solve a problem Mary Margaret was having in trying to look for, trying to use Ngrams to locate intertextuality in Shakespeare, I think. So, or Romeo and Juliet specifically. So I'm trying to write a thing that will extend what we did before with Ngrams and keywords and context to go out and find all of the keywords and then do something with them. So, hello, hi, I'm seeing you in the chat. Hi. So I've got a pretty large corpus that I'm working on, and that's partly what's going on here. That's why it's taking so long. The other thing, though, is that what I'm doing is pretty just memory intensive. I don't know if I'm sure there's a better, like a more efficient way to do this in terms of memory. One thing I could do is instead of like building all this into a giant variable, which is what's happening here, I'll explain in a minute. But one thing I could be doing that would probably save memory would be to write this to a file as it goes, and then write the file in such a way that when I needed part of it, I could just read the file in and parse it, like read the file I wanted and parse it. That would help me save the memory. I don't know if you can see here the RAM on this Google computer, this particular backend that I'm running this on. It's eating up, like this process right now it's gone down a little bit, but it's almost 10 gigabytes of memory just to run this part of it. So I'm basically trying to build a giant multi-level dictionary of all of the Ngrams in this corpus and their locations and frequencies. And it's basically just counting all of them, and it's taking it a very long time. So let me back up a bit. Just for the sake of demonstration today, I'm hopefully going to get to the point where I can work on something that Allison was working on too, but we'll see. All these files here, all these text files that you're seeing me scroll through here, I got these all from Project Gutenberg. When you go to Project Gutenberg, you can look at the list of the 100 most downloaded books yesterday, so that's what I did, and I got those. I ended up with about 80 something, because some of them were duplicates, like there were 2 copies of Frankenstein. Some of them were actually indexes or like tables of contents for other books, so I didn't use those. So I ended up with about 80 new books to add, and I still have my 20 or so Chesterton works. And so my idea is that by looking at this corpus that has this big chunk of Chesterton and a bunch of other stuff, a stylometric analysis should let me identify, like in programming, which of those books are by Chesterton, and then which of the other books not by Chesterton are most similar to Chesterton. That's the kind of thing Allison's trying to do, and I think some others of you may be trying to do that as well. And yeah, there's another bot in the chat. I don't know. It's always that followinbot.com. I don't know what that is, and I'm not going to find out right now. But so this is a large corpus that I think will be more useful for stylometrics, but I thought it would also be fine to try it on this. It might. I have no idea how long this is going to take. It might be done soon. Might not be. It doesn't seem to be eating up a lot of extra RAM as it goes. Like the RAM hasn't been going up, which makes sense. I mean, most of the memory it's already got the stuff stored in its brain here, so it's really just going through and counting pieces of it and then adding up those counts, and that adding up part shouldn't be taking up too much more RAM. It takes a while to process. So let me explain this one, what's going on here. Maybe it'll finish by the time I finish explaining it. And then I also have a tutorial notebook that I made for Alyssa to help show you how to parse text if you have HTML text. And I don't know how many of you have HTML, but this is a pretty useful thing for all kinds of purposes. So this is using a library called Beautiful Soup, which is an amazing library. So hopefully, I just got a warning about my latency on the bit rate, so hopefully it's coming through okay. I mean, the processing that you're seeing happening here, this is happening on Google's computer, not my computer, so that shouldn't be taking up memory on my computer, I don't think, or not much anyway. Let me explain what I've got here. Let me close some tabs I don't need anymore. So this is an extension of the tutorial that I did the other day, where I went through the Programming Historian's tutorial on keywords in context, using keywords in context to find n-grams, I guess. And I wasn't totally sure at the end of that tutorial what to do with that. It seems like you kind of need to know what you're looking for before you look for it, which, you know, there are certainly cases like that. But in the kind of scenario that we have it here, and the kind of scenario that I think Mary Margaret's interested in, we don't know ahead of time what the n-grams are, or what the interesting ones will be, or how often they're going to occur, or which documents they're going to occur in. So I thought it would be possible to write code that would find all of them and then let us search through that. And I wrote, just to kind of help me think through it, I kind of wrote out in just step by step what I think I need to do to solve that problem, and then the code below essentially tries to do that. So this is doing a lot with dictionaries, with Python dictionaries. Actually, let me keep that expanded, just in case we need to look there. So I'm going to first create a dictionary of all of the n-grams in the entire corpus. This corpus is like 110 or so books. It's about 10 million words. Within each of these, it's going to, well, that part, oops, I don't want that. Doing that step one took a while. First I had to read all of the files in. They're still in the folder called Chesterton, although lots of them are not by Chesterton anymore. I needed to make a word list, so it's just a list of all of those words. This is what we did before. And this took a while. I mean, I say a while, it took about 30 seconds or so. This one then made a list or a dictionary out of each n-gram, or each type of gram. So 2 grams, 3 grams, 4 grams, 5 grams, 6, and up to 7 grams. So 2 grams up to 7 grams. Made a dictionary for each of those. No, sorry, I made an entry in the dictionary for each of those, and then for each of those numbers, it made another layer of the dictionary for each n-gram that it found. And I did that actually as a shortcut to only save unique n-grams, so I'm not getting every one. There's going to be lots of duplication within each document. I'm not interested in that yet, although maybe I could have done that in the same step. But building that dictionary took a while, more like 2 or 3 minutes, and it ended up making a very, very large dictionary object of every 2 gram, every 3 gram, every 4 gram, and so on, that occurs in this entire word list. So that took a while. But not too long. And now the thing that it's doing is it's going through. I'm gonna be careful not to click in there because I want it to finish. I don't want to stop too early. So it's going through every file again, and it's converting that entire file into a string this time instead of a list. That's what's happening on line 6 here. And then it's going through each n-gram type, each number gram in the dictionary, and then going through all of them, all of the entries for each n-gram, and then looking for them in this document that we're in right now. So line 3 says for file in files. This is what we're working through. It's going through all of them. It's going through that entire text, and it's using regular expressions to look for that n-gram in that text, and then it's going to hopefully add to that list an entry of the file path and the number of matches. I say hopefully. I mean, I should have written this so that it would stop early or something, and I could just sort of do a quick sanity check to make sure that it was doing what I think it's doing. If this hasn't finished in another 10 minutes or so, I'll just stop it and then try to do a shorter, more verbose version where it actually tells me what it's doing. I think what I should have done is have it, like, it's iterating through files, so I should have had it at the end of each file after it's done with a file. I should have had it print, hey, I'm done with whatever.txt, so that I know that it actually is making progress and I can predict how long it's going to take. But at this point, I have no idea. I just thought, I figured I had the code working, or at least it was doing. I had written what I think it's doing. I mean, and then I just hit go, and then I just wanted to see. This is me trying different things to make sure I understood how regular expressions worked in this context. So anyway, it's going, and hopefully it'll keep going. Keep an eye on it. But while that's still going, I can show you what I did with the other thing, the other notebook I did yesterday. Soup. So this is the one that I did to solve a problem Alyssa was having, or at least actually I think I came up with the suggestion, so it wasn't necessarily your problem, but it was a situation that I saw a possible solution to. And so I wrote some code to do that. My stream is hanging again, or buffering or something. What? Low latency toggle under the advanced menu. I don't know what that means. Hold on, there's a setting that popped up here in Twitch. I'm trying to understand what it's saying. Use the low latency toggle under the advanced. Where is the advanced menu? Okay. I just turned off low latency. I don't know what that means. Maybe it just means that there's more of a lag now between what I say and what you see, but that it's a smoother stream. I don't know. Let's find out. Let me know if it gets weird or better or worse or whatever for you as you're watching. So anyway, so this is a Python notebook that is attempting to read in some HTML and then process it and sort it out, so to figure out who the speakers are. So I did a few things here. First of all, let me show you the documents that I got from Alyssa. And I haven't actually done it on this computer yet. So she's called these for example, panslabyrinth.txt. But these are actually, can I click on the link? There we go. These are actually PDFs, and that's, we need to do some things to them to turn them into text documents. So there are a couple things that are easy, and the easiest is to use something called PDF to text, and you might have that already on your computer just in the command line. If not, this website cloudconvert.com can do that for you. It has that built into it, I think. So you go to cloudconvert.com, select your file, and upload it. This is the one I did the other day. So now that you've uploaded it, you can convert it, and you can convert it to do a couple of different things. Converting it to text was pretty good as far as getting the words, and so if you just wanted the words, that would be fine. But I was interested to see if we could not just get the words, but actually sort through it to determine who's saying what, and separate dialogue from stage directions, because this is a script. And so my hunch was that if we use HTML conversion, the way that it converts it might give us enough of a consistent presentation, layout code, that we could use that layout code to parse the pieces of it that we are interested in semantically. So even though the layout code is not itself semantic, we know what indentation means in the script, and so we can see it. So I'll show you what I mean. So let me switch my screen capture so you can see where to go. Yeah, so this is what the script looks like as a PDF, and what you'll notice is that, for example, the dialogue is indicated by being centered or like, you know, in the middle there. The stage directions are like fully to the left, and so like here's who's speaking, and then here's what they say down here. So those are always indented a specific level, and so since we know how that, since we can see that visually, we can also hook into the thing that is trying to recreate that same visual presentation of it. At least that's my theory. Although I'm looking through this, and I hope I haven't missed anything. It's kind of hard since I haven't seen this movie, so I don't know. It is certainly possible that the code I wrote is missing things. It's kind of hard to tell without having seen the movie. If I, you know, because you can use this code to recreate this script essentially, and one way to sanity check it would be to have my code reproduce this script and see if it makes sense, or if it's missing obvious things. So let's see. So this is the PDF again, and like I'm saying, the trick is you can't just sort of get all of Hostetler's speech, for example. If you were interested in seeing how he uses how his words are used differently than Zelda's words, right? That's the kind of thing we might be trying to do with this. So looking at it in the Python notebook here, this is, oh actually let me finish this conversion. So this shape of water.html, this is now an HTML converted version of this, and if I open it in Firefox, it's first of all, it's an unusually large HTML document, which is kind of interesting, but it's going to take it a minute to download actually. Once that's done, I'll show you what it looks like, and it should look the same. It should look the same as the other one, the PDF, or pretty close to it. Ngram search is still searching. I mean, the kind of process I set up here, like I don't know if this is, like it's hard for me to estimate how long things that are very large will last sometimes. I mean, sometimes I've done things where the process that was running took 4 or 5 days to finish, or something. One of them, it ended up needing to run for like 2.5 months of processing time, something like that. But it partly was probably that I did it in a way that was not efficient. I just couldn't think of any other way to do it. Okay, so that's the case with machine learning kind of stuff, especially. This what we're doing here is not machine learning, but machine learning stuff can be very, very time consuming, process consuming. Somebody's mowing, but I can't tell who. I got to mow on, when was it, Wednesday, finally. Alright, almost done. I mean, it's not a huge file, it's just, I think it takes it a while for the Cloud Convert server to render it. So now this looks a lot like a PDF, right? I mean, it visually very much resembles it, but this is in fact a HTML document. And you can tell by viewing the source, but the source is going to look crazy. The source is going to look very, very strange, but it is consistent and it is complete, proper, HTML. And because of that, we can use Python to parse it, right? So this is what it looks like. Boy. Oh, it's got pages in it too, right? I guess that makes sense. Okay, so this is a mess. Obviously, you can't really read this visually. There's a lot we can do to just clean this out just by deleting things we know we don't need, but let's just leave it like that. Okay, so here I'm going to see if I can do this. I did this earlier on my other computer, so I haven't actually run it recently. But what I did on my other computer is I went through and I did some just find and replace to delete things that I knew were meaningless, that were not useful. Like it has this bit of code in there over and over again, something like 19,000 times, and I don't know why, and it doesn't do anything, so I deleted it. But let's upload that file I just made. Where is that? Where'd it go? What? Didn't I just, where did it go? I was just looking at it. Oh, it's in this area. It's in this weird temp area, which is not what I want. So let's put that in downloads. Okay, so let's try again. Yeah, HTML. Oh, I'm still showing my whole desktop. Hang on. I don't need that. So this is, yeah, there it is. So this is the path to it. This is me reading it. So this is a library called Beautiful Soup. That's a reference to Alice in Wonderland. And you can use it to parse HTML. It's very, very smart. It's a really good library that's very useful. The guy who wrote it, Leonard Richardson, is an interesting guy. He makes a lot of Twitter bots and things, or he used to. I haven't seen much from him lately. And he also wrote a pretty good novel called Constellation Games. It's not a great title, but it's basically about, it's a good idea. It's an interesting premise. It's about basically a group of aliens contact Earth and want us to join the equivalent of the Federation, like in Star Trek. And the person we learned about this from is a pretty low-level kind of guy who his whole job is he's a video game reviewer, and so he, as these aliens are kind of integrating themselves with society, he gets to know them by playing their video games and writing reviews of them. So it's pretty funny. It's a pretty funny book, pretty interesting space opera kind of science fiction, if you like that kind of thing. Constellation Games by Leonard Richardson. So what I found by looking at this was that it seems like things that have this class name, x1f, x2, 0, x1e, that x seems to be a like space left and right, like how far over to the left or how over to the right a particular text is. And so using that, I was able to infer that that's the speaker's names, the dialogue, and the stage directions and so on. So just to test that, we can try it out here. So this one, I haven't gone through and removed all those weird, unnecessary things yet. The span class _2, that thing, I have not gone through and cleaned that out yet. But that's the idea. I mean, this is you can see the speaker's names there, and I can actually clean this out before parsing it as soup. So let me try that. This is quite long. It occurred to me. So let's do that here. So before that, actually, you know what, I could probably just do it right in the read. Let's just do a quick little replace here. So we're going to be looking for span class equals __2, and then we're going to replace it with nothing. So that should probably get rid of that. Let's see if this looks better. It does. Okay, great. So that's the list of all the speakers. Hopefully, it is certainly possible that I'm missing some. In fact, I feel like I am if I look at that, because I don't remember it starting with dialogue. Let's take a look. This is still processing. So I'll see if I can fix what's going on here. Yeah, so it should be Giles narrator should be the first dialogue speaker, not dialogue, right? So there's something I'm missing here. But then it goes on to Giles, and so on. So what we have to do is look at that part of the HTML and see what is different about it. Yeah, X18. No, wait. Is it that one or that one? Which one am I on? Yeah, Giles narrator is X18. Okay. I wonder what else might be X18. So we can try that just here and see if that is something that's used more commonly. Oh, it is. Okay. Interesting. So I am probably missing a fair amount of dialogue. That seems, yeah, that's what I was afraid of. Okay, so let's do, what was it, X1F before? Let's look for both of them. I think this is how we can do both of them if we just make it a list. X1F. Okay. Okay, so I don't know if you're following this list, but this is something that would be worth checking on. Again, you can probably check it more easily than I can because you've seen the movie and you know what you're looking for. And it's a good point that you're right that if there's two mute characters, we aren't going to be getting their dialogue at all. So we need to find other ways to gather the words that appear around them. And we can probably figure that out, right? Like, is that, like, is the creature named, or is it just, yeah. I mean, creature is a word that doesn't seem to appear. Oops, I'm not. Yeah, creature doesn't appear to show up in here. So yeah, I don't know. But Elsa, or is it Elsa or Elisa? Elisa, I don't know. Either way, those are things we want to try to. If that's what we want to figure out. Oh yeah, just Elisa. If those are things you want to know about it, then we have to do a little bit more to figure out how to parse that. But I think this is the right approach in the sense that these X classes are what give us that sense of where we are. Okay, you know what? I wonder if I can just make a copy of this and then leave this one running. Yeah, so this one, we'll just let it keep going. Maybe that'll get done. But I'm going to try this again, and I want to see if I can make it be more verbose and print its progress, because that might give us a sense of like why this is taking so long, and whether or not it's going to actually produce anything. So let me get this one going. This is a copy of the one that I've already shared. Okay, Fishman asset creature. That's so weird and dehumanizing. But I think it'd also be interesting in the context of your thesis to look at both the words that are used in the script, like to describe what that character does, like stage directions, as well as words that other characters use for that character. For example, you might infer that a character who thinks less of him might call him the creature. Someone who is more sympathetic might call him Fishman. I don't know if Fishman isn't that great either. But yeah, I guess I should see that movie. Okay, so let's try this. This one is still going to take me a minute to get it built back up to where this cell started processing now. Yeah, almost 40 minutes ago. But let's see if we can get that. All right, so this is going to build a word list. This will take a minute or so, I think, maybe less. And again, this is great because this is running on Google's server. It looks like I'm not going to be able to get to Allison's thing, the stylometric. I'm trying to think of what the right word is for that, but that's something I know how to do it. And I don't think it'll. I mean, I have an idea for how to do that. I don't think it'll be that. I don't think it will be as processing intensive as what's going on here. It shouldn't be. It will basically be generating a hash for each book in this corpus, so it's like 100. And then once I have those, then I will just be dealing with those and not dealing with the words themselves anymore. Just watching some drama over here at the bird's nest. A bunch of grackles just showed up on the ground, and the cardinal. Oh, no, I thought the cardinal was going to try to muscle in on him, but he's not. He's about 3/4 their size, so, and there's like 10 of them. So yeah, and the grackles I've noticed have been really. I mean, they're pretty. Like they fight each other a lot. I don't know what's going on with them. I usually don't see this many of them at once, but they'll do this thing where they like swell up and like puff themselves up and yell at each other for a while. Okay, great. So this was done, right? We just made the giant word list. So this one's going to take a little bit longer, I think. This is going to actually build the n-grams list. It's really a list of n-grams, but it's a dictionary because that when I make it a dictionary, that forces them to be unique items on the list, and that means I don't have to process later, and it also saves memory. But what you'll see is this is still going to take a ton of memory. The RAM up here is going to start climbing up pretty soon. I think probably as it gets through each number gram. So I think it starts with 2, then 3, then 4. It's going to start going up pretty soon. Okay. All the birds are gone because my son is out there now swinging on the swing set. He's got himself inside both swings. There's 2 swings and he got himself in the middle in both of them. And now he's swinging between them. It's always just a matter of time before he gets hurt because of trying something that he shouldn't. Okay. He's trying to do a pull-up now. Okay. Well, this is still going. Yeah, the RAM is doubled. Not much to do except wait for this one to be done, and then we can start. Well, I can start actually down here. I can do a little bit to start making this more verbose while that's finishing. So what I can do is first of all have it tell me when it's done. So I have to watch my indentation levels because this is Python. So I'll just have it say print done with file. I guess I could also have it parse a smaller subset of these files. I just don't know if that's going to be interesting or not. And I'll write this one so I can stop and start it so that, because I have the real processing happening in another tab still. Okay, great, it's done. So this will tell me at least when it's done with a particular file, and that will pretty quickly tell me just how long this is actually taking. So this is the same process that's happening here, but the only difference is it's printing that it's done whenever it's done. If it's ever done, I guess. It shouldn't take, each individual file shouldn't be enormously time consuming. But there are a lot of files, so altogether it could take a while. fact that I don't have an answer yet, that's not done with the first one yet. Feel like it should be done by now. Oh man. Okay, so we'll check on that in a minute, but just to kind of see what it's working with. So all gram dict is the big object. So all gram dict 5 is going to be a list of all of the 5 grams. It's actually going to be, these are all keys, and so if I want to see how many 5 grams there are, I can count. Well, it's actually not going to let me do these things twice, is it? It's going to have to finish the other process before it starts the next one. But I did this at one point earlier, and you can see the number was, it was tens of thousands of 5 grams. I want to say it was around, yeah, I don't know if I ever, I know that the number of bigrams was smaller than I expected. It was around 2 million. And the number of trigrams were a little bit more than 2 million. I don't know, we're still not done with the first file. So this really just could be too much. Too much to ask here. I mean, I'm doing this on a very large, I mean, for this kind of thing, a very large process, or corpus rather. So maybe that's all that's going on here. I really want to get this done so I can actually show you something though. Because the next part of this would be the actual interesting part. Oh man. Still not done with the first file. Well, let's just give ourselves a break here. I mean, another thing that occurs to me, it could just be that it's really, I mean, the basic thing that it's doing here, and this tells you a bit more about that. I hit stop, and it tells me what step it was on when I stopped it, and it's on this step, which is it's using regular expressions to find a string within another string. There might be a faster way to find strings within another string, even for very long strings like this. Some other languages have what's called a substring match, which might be more efficient in this case because I don't really need a regular expression, wildcards or anything like that. I just don't know how Python, if Python has a substring. I mean, okay, let's see. I mean, this is partly it. I know I can find out if it's in that string, and that's, you know, there. What is find? Because I don't want to know just is it there. I want to know how many times is it there. I wonder if that's. I'm not familiar with Python find. I don't get that. Okay, so this is what I was testing earlier. I just copied this definition of lorem ipsum, and then I did a regular expression thing on it. But let's say if I wanted to just find, let's just try it. So let's do. Oh, well, okay. Let me define it first, and then try it here. Okay, but see, it doesn't. I mean, find just finds the first instance of it, which is at index 7, which that's fine. And the way that this works, like if it's not found, like if you just type something in here, it should give you -1. Yeah, okay. I wonder if there's a find all that's not attached to regular expressions. There is not. Okay. substrings. How to find all externals. Somebody has the same question as me. There's no simple. But you could use regular expressions. Yeah, I could, but I'm trying not to. Well, this is an interesting idea. So someone has written a find all function. It's really a constructor. Huh. This might be faster. I guess it would be interesting to try. So this is what we do in this situation. We copy someone else's code in and see if we can make it work. So this is what I usually do. I copy it in and then I copy where I got it from into a comment so that I can look at it. I can give credit later, and also I can follow up again if I don't understand what I'm doing with this. Okay, so this is something called find all. Let's see if this works. Looks like it wants me to do find all lorem dummy. Okay, that's what? Oh, I need to turn it into a list because it's a generator, not a function. Okay, so that does work. I mean, it's worth a try. So let's see. This might, if this is faster, this would be great. So this is the part where it's actually doing that, and this is the part I don't need so much anymore. But let's keep that there while I'm writing the substitution for it. So I want to do matches. I'll just use the same variable here. Matches equals list find all ng is my ngram at the moment. No, I'm searching words is my, yeah, and then ngram is my, words is the haystack and ngrams is the needle. So let's see. So I do want it to append, I do want to actually record zeros. So if matches is 0, then that's okay, I think. Let me just make sure that that's okay with what the constructor is going to do here. Yeah, okay, that's fine. So it's going to be storing that as a tuple. Let's just see, maybe it's faster. And again, this is going to be printing when it's done with the first file, so that should I mean, if this happens within a minute, that would be faster than what we have now. You know what I could also do? Hold on. Just to give it even more of a chance to tell me how it's doing. So this is, it's found it and it's stored it in matches. This will slow it down, but I'm just going to keep this in here while I'm testing. I'm just going to say, if you find some matches, go ahead and tell me that you found a match. All right, so I found ng lin matches time. So this, I mean, this will take processing to do this, but just while I'm testing, this will be good to tell me. I'll make it make it excited. I'm going to give it an exclamation point when it prints it out. So let's see if it actually is doing anything. No, wait, what? Must be string, not int. I know. should be a string, not an int. And I'll put quote marks around, and then the engram. Okay, see, this is right, so it's working. It just has a lot to do, I think. So yeah, let me stop that. So it's running. Stop. Stop. I can't. It's running. It's printing out so fast it won't let me stop it. But that you can see it's going through and it's telling me that it's finding each of these engrams a certain number of times. And so I mean it is at some point going to be done with the bigrams. I wish I could stop this. I don't know why it's still won't let me stop it. I can clear the output, but okay, wait, did I just delete that whole cell? No, it just jumped me way down here. Stop. Okay. So that was good. I mean, that tells me something really useful, which is that it's doing what I thought it was. It's just taking it a lot longer than I thought to do it. So let's see if we can have it give me more of an update here. I'm going to have it do. I'm going to take this one off. I'm going to see how long it takes to get through the 2 grams. Maybe that would help me. Or for the I'll have it tell me what in it's on. So I'll do that here. Wait, this should be here. Wait, have I done this wrong? I'm looking at my indentations. I might have. I don't need this here. I need this back a level. Now I think I need to print done with the it's done with the engrams for that file. Right. Yeah, this goes back here. Okay, yeah, I think I might have had my nesting wrong. Let's try it. So I'm not going to be printing every match it finds. It's still, at this point, it should tell me when it's done with the 2 grams on the first file, then the 3, the 4, the 5, and then it should tell me that it's done with whatever file that is. Alright, let's try this. So my process running in the other tab that now has been going for over an hour might be unnecessarily... Like, I'm really not sure what difference it'll make, but anyway. I'll see how this goes. If this doesn't give me anything in a couple minutes, then I don't know what I'm going to do. But I will shut down the stream at that point. And I'm really, yeah, I wish I can get this working. What are y'all doing?
We are making saldo maps of the Democratic Republic of the Congo. For some reason.
What do you mean for some reason?
I don't know why. Exactly.
Okay. Well, I'm trying to parse all of the engrams in a pretty large corpus of text here, and it's sort of working, but it's taking forever. I could also have it sort of, I can make a progress bar basically by figuring out how many engrams there are, how many bigrams and trigrams and so on there are, and then show you how many it's done. I mean, a progress bar obviously is a pretty convenient way to understand what's going on. I don't know. Well, I've had the stream going for about an hour. I have not really produced much yet, but I feel like this is the right approach. I need to do a bit more to understand what it's doing to see if it's going to actually be done in a reasonable amount of time. So I'm going to close this down, and you know what? Actually, I'm going to try one more thing before I close it down. Sorry. Let me try one more thing. Let me just try this. Let me start this over again. This whole thing here, but instead of reading all 120 books, let's just try to read the ones. Let's just try to read a couple of books, like a much smaller set, and then see if maybe that will, you know, it'll just give it less to work with, and maybe it'll get through it faster, right? So let's see. I could just get, yeah, I've got 3 books by Jane Austen. Let me just do those and see if this basic workflow even makes sense. So all my functions would be the same, except now in my glob path, I'm looking just for, the glob pattern is just going to be anything starting with Austen and a hyphen, Austen hyphen. So this will be a much smaller corpus than what I had before. It should process it a lot faster. So yeah, you see there it's already done, converting that to a bag of words. And so let's convert that now to a dictionary of n-grams. And again, this should be a lot faster, and it was great. So this one now, this bit here should go faster. But before I try that, let's just kind of see a couple of things I was trying to show you earlier. So this is, K is now the number of 5 grams, 401,000 5 grams, which is pretty high. So let's see see if this processing thing that I was doing is actually going to complete any of them. I guess I should have seen how many bigrams there were. Okay, still not even done with the bigrams. Not using nearly as much RAM though, so that's good, and you'd think it would be going faster than this. Alright, well, I'm gonna shut this down. I'm gonna keep playing with this for a bit, and if I figure this out, I will let you all know. And I will share it in, I might even just start a new stream and see if anyone's able to watch it, just so it's recorded. But I'm gonna shut this down. Sorry it's not working yet, but I feel like I made progress on this. I thought this would go a lot faster than it did. So I'm going to rethink my assumptions and see if I can figure it out. What?
Mr. Parrot. What? Mr. Parrot.
What are you talking about?